Alright, this is a quick read-through of Cramer's rule as presented in the book by Mr. Heffron, right here. Linear algebra. Right, where is Cramer's rule? It's in the chapter about determinants. Let's have a look. Chapter 1, Chapter 2, 3, Chapter 4. Here we are. Topic, Cramer's rule. Let's pick that and see what he says. That's the wrong one. Let's go back up a bit. Cramer's rule. Here we are. Scroll down. And this is what we'll look at right here. Okay. What does it say? Cramer's rule is right here. If you have a matrix A and determinant is not 0, then the system AX is equal to B. We're used to that. Maybe notations is slightly different, but we have a linear system written as AX is equal to B with determinant of A not 0. Okay, so this system has the unique solution. Well, that's not a surprise. We know that because determinant is not 0. So the system AX is equal to B has the unique solution. Oh, and they give us the solution. That's what Cramer's rule is. How nice. So x1 will be determinant of b1 divided by a. x2 will be determinant of b2 divided by determinant of a. Oh, and in the solution, obviously, I'll have x1, x2, x3, and so on. We're quite used to saying x, y, z, then it would just be x1, x2, and x3. So we know what determinant of a is. What's b1, b2, b3, and so on? What are they? What's B? Matrix BI, it's a new matrix. It is formed from A, your original matrix, by replacing column I with the vector B. Alright, what does that mean? So I start off with my matrix A, and I will replace one column with the vector B. Vector B is my right-hand side of my equation. So I'm going to do this many times. To find my x1, I'll remove the first column, column 1, and I'll replace it by vector b. Then I'll find my determinant, divide my two determinants. I'll do this again for x2. I'll replace the second column, column 2, with vector b. In my matrix A, I'll have a new matrix, I'll find the determinant, and I'll divide by my determinant. If it sounds a bit confusing, how about we try and pick an example? Okay, let's have the example they're suggesting in the book. Let me remove this and write this again. Or maybe we can't. Alright. So I have a matrix here, matrix A. Vector x is equal to right-hand side B. AX is equal to B. So I'm wanting to solve this system, but only for x2. Guy in the middle right here. That's all I want. Cramer's rule says what? x2 will be equal to a new matrix, which I'll come back to in a minute. The determinant of that new matrix divided by determinant of the original matrix. So is this matrix, matrix A? Yeah, it is. It's right here. It's the same. And that's the determinant. Then you just have to calculate that. What's the determinant at the top? I'm trying to find x2. So it should be, this matrix here should be exactly the same as I had. But because I'm trying to find x2, column number 2 should have been replaced by B. Yeah, and that's what it is. I've got A right here. This is the same except for the second column that's been replaced by B. Find the determinant of that. It's a number. Find the determinant of that. It's going to be another number. Divide one by the other and you're done. That's how you find x2. That's Cramer's rule. Let's try to find x1. x1 will be what? Downstairs would be determinant of A. Now that's what's nice about that, is that you only find determinant of A1. So obviously once you have that number, you're done. So determinant of A, that's what we divide by. What's going to be at the top? It's x1, so I should replace my column number 1 by B. b, which is right up here. Okay, so 2, 1, minus 1. And then everything else is the same as I had in a. So 0, 1, 0. And it's a bit crammed. 4, minus 1, 1. Determinant of this. Can I move this? Can I please move? No, I can't. Okay. So that's equal to this determinant at the top. Oh, there are lots of zeros. How nice. I'm going to go along the first row. Right here. 2 times 1 minus 0 plus 4 times 0 minus 1, 4 times 1, divided by original determinant of a, which I'll let you find. So that's going to be 2 plus 4, that's 6, divided by the determinant of a, which you will have already found if you've done this one, and you're done. And that's what Cramer's rule is. So it allows you to find a solution, as we always do. Oh, that is odd. Find a solution as we always do, but then the nice thing about that as well is if you're only looking to find one of your entries in your solution vector, then you can find it that way. And if you want to find them all, it's going to be quick because it's just calculating loads of determinants. And by now, I'm sure you're very good at calculating determinants. That's it. That's what Cramer's rule is.